Okay, today we're going to be doing problems 939 to 944. I think all of them are actually somewhat difficult, so we're going to at least touch on all of the questions. First one is 39, and it says, which of the expressions below is a factor of 6x squared plus 7x minus 20? First thing I would do is, I always use this analogy of just put it into smaller numbers. Think about the number 72. What are factors of 72? Well, that means numbers that go into 72 evenly, divide into 72, such as 9 is a factor of 72, 8 is a factor of 72, 1 and 72 are both factors of 72, and there are more. So there are a lot of different ways you can break 72 down. 6x squared minus or plus 7x minus 20 really only has one way that it can be factored, at least that we've learned so far. So the first thing we need to do here is pick a method, and the method that we've been using has been the factoring with the generic rectangle. So we put 6x squared up here and negative 20 in, and now we can create a diamond, negative 120x squared and positive 7x. So now you need to pick the two values in here that multiply to be negative 120, add to be 7x. Afterwards, you'll pull values out, and you'll get two sets of parentheses. Okay, if you need more details on that one, just go to HotMath, or if you're sitting here, check with your neighbor. Okay, number 40. It asks, which of the following expressions is the product of this? So remember, I want you to get the idea in your head, the concept that product and factoring are opposites. So if you look at 39 and compare it to 40, 39 has something that's already been multiplied and we are factoring it. 40 has something that is already factored and we will multiply it. Our method of multiplication was the exact opposite. It was using the generic rectangle but with length and width as opposed to actually finding the length and the width. So 4y minus 3x on top, 2y plus x on the side. Some of you might have put 2y plus x on the top too. That's great. If you multiply this out, you'll get 8y squared, negative 6xy, positive 4xy, and then in the bottom left, negative 3x squared. When you combine all this, 8y squared's first. The only two things that can be combined here are these two, and 4xy minus 6xy, that's negative 2xy, and then subtract 3x squared to finish. Okay, so that was multiplying. That should have been a review from a couple chapters ago. Number 41 is all about differences, and you will see in class, the next class, about why exactly we're talking about these things. And you'll see absolute value has a lot to do with it. The first one, they give you these two people, Rocio, I guess, and Thomas. And Rocio has $298 and Thomas has $314. Well, when you take the difference, let's just say you did 298 minus 314. You might get negative 16. But what we'd say is, what's the difference between them? We wouldn't say negative 16. We would say 16, right? If you're asked, you know, oh, someone's taller than you, they're 6 inches taller, you wouldn't say, oh, the difference between us is negative 6 inches. You'd just say, oh, there's a 6-inch difference. And so you'll see the rest of them will remain positive as well. Negative 23 to 19, if we do negative 23 minus 19 to find the difference, we will get negative 42. And again, the difference between them is not a negative value, but a positive one, 42. Okay? If, by the way, you did it the other way, you'd get 19 minus negative 23, and you'd end up with positive 42 anyway, so this way would get you right to the positive answer. So you should be picking up this idea, I hope, of absolute value. Part C, 1850 is the number of students in one high school, and oh, I just realized I wrote it down wrong. 1,490 is the other one. So take these two things and subtract them. 1850 minus 1490. So you should get 360. So there's the difference, 360. And part D says explain why they're all positive, and I hope I've already addressed that issue. Number 42 is solving equations of different kinds until part D, where you're solving an inequality. And I really want to stress the difference between an equation and an inequality. So first, you're thinking 3 divided by some number gives you 9. That might be a little bit tough for you to think about. So put this 9 over 1, and now we've learned cross multiplying before, so 3 times 1 is 3, 9 times x is 9x, divide by 9 on both sides, and we get 3/9, which is also known as 1/3. 1/3 equals x. 1/3. Okay, part B, we're looking for the square root of some number is 4. Well, a square root is asking, I need a number times itself to give me this number under the root. So 4 times itself, oh, that's 16. So the square root of 16 would equal 4, and we get x equals 16. Another way for you to think about this is the way of undoing a root is to square it. Okay? Whatever we do to the left, we do to the right. Now on this problem down here, x squared equals 25, think, I need a number times itself to give me 25. And of course, we're all comfortable enough to say that's 5, but it's also negative 5. I want you to think about why for a second. Okay, another way of thinking about it is to take the square root of both sides, because we talked about squares and roots undoing each other up here. Well, squares and roots, again, are going to undo each other. The square root of 25 says, what number times itself is 25? Well, 5 and negative 5. Both times themselves are 25. The next one is an inequality, slightly different. The first thing is to distribute 2x minus 6 greater than 4. Add 6 to both sides. 2x is greater than 10. And then divide by 2 on both sides. X is greater than 5. If, by the way, you were to graph this, you would have it graphed on a number line, not on a coordinate plane, because there's only one variable. 43 is a question about Bernie and Barnaby. Isn't Barnaby a great name? Bernie runs 9 meters every 4 seconds. So the rule for Bernie would be something like this. 9/4 x times, and maybe they'll give us a start, maybe they won't. Barnaby, it says, runs 2 meters every second. That's a rate, so we're going to right there put that in as our slope. Oh, and he gets a 10 meter head start, so we add 10 to it. Now, the question says, if the race was 70 meters long, did Bernie ever catch up with Barnaby? My strategy here is, let me just find out where they meet. And then if they meet below 70, well then yes. If they meet after 70, then no. So, and remember, we're talking about meeting in meters. So the first thing here is to set them equal using equal values method. Subtract 2. You can think of this 9/4 as 2.25x. Subtract 2, you get 0.25x equals 10. Divide by 0.25 and you get 40. Don't answer yet though, because 40 is seconds. We need to take that value and plug it in to see exactly how far they are. So 2 times 40 plus 10. Oh, it looks like they meet at 90 meters. So if the race is only 70 meters, they will not meet. They will not meet. Okay, and the last one, we have 2 methods of finding roots. One is factor and ZPP, or zero product property. Okay, and the second one is to use a quadratic formula. Remember the factoring, we're going to set up a generic rectangle. That is the world's ugliest generic rectangle. And the quadratic formula, A equals B equals C equals, in this case it'll be 5, 7, and -6. And then you've got to take your calculation forward. Here you'd have to factor in your zero product property. All right, that's that.